There are moments in racing history that never make it into the record books. Moments that happened in the pits, in back rooms, in rules committee meetings where decisions were made not for the good of the sport, but for the survival of the men who controlled it. This is one of those moments. In 1969, Mickey Thompson built an engine so mechanically brilliant, so aerodynamically advanced, and so far ahead of everything else on the drag strip that the men running American drag racing had only one response. They banned it. Not after it lost, not after it failed. Before it could ever prove what everyone in that paddock already knew, that Thompson had just made the American V8 look like yesterday's machine. This is the story of the 1969 Autolite Inline engine. The masterpiece NHRA was afraid to let race. Settle in. This one matters. If you grew up watching motorsport in the 1950s and 60s, the name Mickey Thompson meant something. It meant speed. It meant precision. It meant a man who looked at problems everyone else had accepted and solved them. Daniel Sexton Thompson was born December 7, 1928, in San Fernando, California. From the time he could hold a wrench, he had one obsession: going faster than anyone had gone before. Not for ego, not for money. Speed for Thompson was a language, and he spoke it more fluently than almost anyone alive. He understood early that racing wasn't primarily a test of bravery. It was a test of intelligence. The bravest driver in the world loses if his car is built wrong. Thompson approached every mechanical problem the way an engineer approaches a calculation: systematically, precisely, and without sentiment about the way things had always been done. That attitude made him great, and it eventually put him on a collision course with an institution whose entire identity was built on the way things had always been done. In 1960, Thompson became the first American to travel 400 miles per hour on land. 400 miles per hour. In 1960, driving the Challenger 1, a car he designed and built himself at the Bonneville Salt Flats. While the established racing world was still counting cubic inches, Thompson was thinking about aerodynamics, airflow, and what a vehicle's shape meant at speeds almost no land machine had ever reached. He was thinking the right thoughts a full decade before the mainstream caught up. Then he took those same ideas to Indianapolis. He brought rear-engine cars to the Indy 500 when the establishment openly laughed at the concept. The traditional front-engine roadster was sacred at Indianapolis. You didn't touch it. You didn't question it. Thompson questioned it. His cars ran competitively. Within a few years, every car at Indy was rear-engined. The men who laughed had to spend fortunes rebuilding their programs around the idea Thompson had introduced. He redesigned racing tires. He pioneered chassis geometries. He created stadium off-road racing. He was not a fringe figure with a wild idea. He was one of the most accomplished and consistently proven innovators American motorsport had ever produced. When Mickey Thompson said he had built something that would change the game, you paid attention, because every time he had said it before, he was right. In 1969, he said it again. To understand what Thompson was challenging, you have to understand what the American V8 meant in 1969, not just mechanically, but culturally, commercially, and politically. The V8 wasn't just an engine, it was an identity. 8 cylinders in 2 banks of 4, firing in sequence, producing that deep, unmistakable rumble that rattled the ground and made the hair on your arms stand up. If you've heard a properly built American V8 at full throttle, you know exactly what I mean. Nothing in the world sounds quite like it. Chevrolet had it. Ford had it. Chrysler had it. The entire industrial machinery of American performance, the parts suppliers, the machine shops, the engineering departments, the RA. Sing Teams was organized around one foundational assumption. This is what an engine looks like. This is what performance means. In pro-stock drag racing, the V8 was absolute law. The Chrysler Hemi was producing over 600 horsepower in competition trim. The big block Chevys and Ford 429s were right behind it. Teams were spending enormous money developing these configurations. Engineers who had spent entire careers mastering V8 breathing, combustion, and valvetrain dynamics were at the very top of the sport. And here is the critical point. Every word of the NHRA rulebook had been written around this reality. Every weight break, every displacement calculation, every classification formula, Every technical inspection procedure, all of it built on the foundational assumption that the engine in a competitive drag car would be a V8. Nobody had seriously challenged V8 dominance in American drag racing because nobody had built anything capable of matching it. Until Thompson. Thompson had been watching pro stock carefully, and he identified something the entire establishment was ignoring, not because they were stupid, but because they had no incentive to ask the question. He looked at a pro stock car from the front and asked something simple. Why is this engine so wide? The V8 configuration is inherently broad. Two banks of cylinders extending outward at an angle creates a large engine package that fills the bay with bulk. That bulk translates directly into frontal area, the surface the car presents to oncoming air as it races down the strip. At the speeds pro stock cars were hitting by 1969, approaching 150 miles per hour, aerodynamic drag is not a minor consideration. It is a measurable, calculable force. Every extra square inch of frontal area creates resistance. That resistance costs speed. That speed costs hundredths of seconds. And in a sport where hundredths of seconds separate national champions from also-rans, it is real money and real championships being bled. Away. The V8-powered Field of 1969 was carrying more aerodynamic drag than necessary. Not because engineers were careless, because the engine configuration everyone used created a shape nobody had seriously tried to change. Thompson was about to change it. The 1969 Autolite Inline engine was a reimagining of internal combustion architecture built specifically for the demands of quarter-mile drag racing. Instead of the V8 layout cylinders spreading outward like an open hand, Thompson arranged his cylinders in a single narrow line, an inline configuration. The result was an engine profile dramatically narrower than anything the competition was running. Before you say it, yes, inline engines were not new in 1969. Straight sixes had been around for decades. Inline fours were common in economy cars. But building an inline engine for economy car use, where peak output might be 100 horsepower, is a completely different challenge from building one that has to compete with 600 horsepower. Hemi engines on a national drag strip? Thompson wasn't just building an inline engine. He was building a high-displacement, high RPM, competition-grade inline engine that had to match or beat the best V8s in the country while maintaining the narrow profile that was the whole point. That is an extraordinarily difficult engineering problem, and Thompson attacked it with the same precision that had produced his Bonneville records and his Indianapolis innovations. The foundation of the concept was aerodynamic advantage. Reduce the frontal area of the silhouette the vehicle presents to oncoming air, and you reduce drag. Reduce drag and you get higher top speed for the same power, better acceleration efficiency in the upper portion of the run, and a car that simply works harder with every horsepower it makes. Thompson's calculations showed that the aerodynamic advantage of his narrow inline profile, combined with intelligent chassis and body design, could offset a meaningful power deficit against wider V8 configurations. His engine might not need to match a Hemi's peak horsepower if the car carrying it was producing less resistance. The physics would carry some of the load. But Thompson also knew the engine needed to genuinely compete on power. So the engineering challenge was this: build sufficient displacement, solve the specific problems that arise in inline configurations at high RPM, and do it all within the narrow package that made the concept viable. The breathing characteristics of a high-displacement inline at competition RPM are different from a V8. Crankshaft dynamics are different. Thermal management is different. Every difference from conventional V8 practice was a problem Thompson had to solve from scratch because there was no playbook for what he was building. He developed new cylinder head designs for the inline-specific flow requirements. He engineered intake systems that maximized air delivery within the narrow packaging constraints. He worked through exhaust routing that had never been attempted in competition drag racing. Beyond the engine, Thompson was thinking about the complete package. A narrower engine meant a narrower, lower front end. A lower front end meant less frontal area. He was designing engine, chassis, body, and aerodynamics as a unified system, not dropping a bigger engine into an existing car and calling it done. By the standards of 1969 Pro Stock, this thinking wasn't just advanced. It was from a different era entirely. When Mickey Thompson arrived with his Autolite Inline car, the Paddock reaction told you everything. Experienced crew chiefs, men who had spent 30 years around racing engines, men who could diagnose a problem from sound alone without opening a hood, stopped what they were doing and walked over. They crouched down. They looked at the engine from different angles. Some of them went quiet and stayed quiet because they understood immediately what they were looking at. This was not a stunt. This was not an experiment thrown together for headlines. This was a legitimate, sophisticated racing machine built by one of the most proven minds the sport had produced, and it was built to win. The men who understood the engineering could see it without being told. If this thing performed anywhere near what the physics suggested, it would force every team in the sport to question the entire premise of their program. All that money, all those years of V8 development, all those relationships with engine builders and parts suppliers suddenly pointed in the wrong direction. There is a particular silence that falls over a professional paddock when something genuinely new appears. Not admiration exactly, more the silence of calculation. Everyone running the same rapid arithmetic. What does this mean for us? Can we copy it? How long do we have? That silence fell when Thompson's car rolled in. The NHRA technical inspectors arrived, and what followed over the next several hours set the course for everything that came after. They measured. They consulted a rule book written entirely around the V8, which meant it had significant gray areas when confronted with an engine that didn't fit the expected shape. They argued among themselves. They called in senior officials. They wrote extensive notes. And then the conversations moved to rooms where the press and competitors couldn't follow. Thompson stood back and watched. He had done the work. He had the documentation. He knew his concept was sound. He had brought new ideas to skeptical establishments before at Bonneville, at Indianapolis, and he understood the initial reaction to genuine innovation is almost always institutional resistance. But what came next wasn't just resistance. It was strategy. The NHRA did not dramatically ban Mickey Thompson's Autolite Inline and hold a press conference. That would have been too obvious. That would have required them to state plainly why they were doing it and any honest answer. What would have been devastating? What happened was more sophisticated and more corrosive. What happened was a sustained series of interpretations, classifications, and rule adjustments that applied specifically to the characteristics of Thompson's design and consistently, predictably, disadvantaged it. Weight penalties were applied that directly neutralized the inline engine's aerodynamic and weight distribution advantages. The classification system, built entirely around V8 assumptions, was interpreted in ways that placed Thompson's car in a competitive bracket where its natural advantages were canceled by artificial penalties. The physics of the inline configuration, the very things that made it promising, were identified, and rules were built around them to eliminate their benefit. Displacement calculations written for V8 engines were applied to the inline architecture without acknowledging the fundamental mechanical differences between the two. Technical definitions that were ambiguous because they had been written before anyone imagined an inline engine would appear in pro stock were resolved consistently against Thompson. Every time Thompson's team modified the car to satisfy one ruling, a new interpretation emerged. The goalposts didn't move in one dramatic moment. They moved in small, incremental, always in the same direction steps that accumulated into an insurmountable disadvantage. Some will say the NHRA was simply doing its job, that sanctioning bodies have to make judgment calls when new technology appears outside existing categories. That reasonable people can disagree about how to classify something genuinely unprecedented. That is fair as far as it goes. But consider this. The NHRA in 1969 had deep financial relationships with General Motors, Ford, and Chrysler. These manufacturers were not passive observers of drag racing, they were active participants, funding teams, supplying parts, using the sport as a direct marketing vehicle for strength and cars. The muscle car era was, in no small part, a commercial exercise conducted at NHRA venues. Fans buying Chevelle SS396S and Plymouth Hemi Roadrunners were influenced by what they saw at the strip. All of that marketing value was built on the V8. Thompson's Inline wasn't just a faster design, it was a commercial threat to a multi-million-dollar ecosystem. If it succeeded, if it proved a narrow-profile engine in an aerodynamically optimized car could outrun Hemis and the big blocks, the questions it raised about V8 supremacy were questions Detroit did not want asked. Ecosystems protect themselves. And the American V8 ecosystem of 1969 was large, powerful, and highly motivated to remain exactly as it was. Thompson fought. He appealed. He modified, resubmitted, and engaged with the process with everything he had. But the process was designed, whether consciously or not, to exhaust him. Eventually, as it does for most men who challenge powerful institutions without matching. Institutional support, the bureaucratic weight won. The Autolite Inline never got the clean, fair, competitive opportunity its engineering deserved. It is one of the genuine losses in American motorsport history. Here is what the passage of time has made undeniable. Mickey Thompson was right. The aerodynamic principles behind his inline design are not theoretical. They are documented physical realities confirmed by decades of motorsport engineering. The relationship between frontal area and aerodynamic drag is among the most fundamental concepts in vehicle dynamics. Reduce frontal area, reduce drag, gain speed. It was true in 1969. It is true today. The V8 is inherently wider than a comparable inline. That is geometry, not opinion. A narrower engine allows a narrower bay, a lower front end, less frontal area, less drag, faster elapsed times for the same power output. Every step in that chain is real and measurable. The NHRA's officials understood this in 1969. That is precisely why that inline configuration-specific advantages were identified and systematically penalized. Engineers who have studied the Autolite Inline since have reached a consistent conclusion. The concept was sound, not theoretically promising, genuinely practically sound for the specific demands of pro-stock drag racing as it existed then. Given fair competition and proper development time, the inline design had every legitimate reason to perform at or above the level Thompson projected. The thinking Thompson applied in 1969, treating engine, chassis, body, and aerodynamics as a unified system, would not become standard engineering practice in American motorsport until the 1980s. What he considered in 1969 as a competitive necessity, the sport spent the next 15 years slowly rediscovering. He saw it first. He built it first. He tried to race it first. And the institution charged with advancing the sport decided the sport's advancement could wait. Some cars win championships. Some cars change the sport. And the rarest kind, the kind that forces an entire establishment to confront how much of its identity is built on tradition rather than truth, those are the machines that get suppressed. Mickey Thompson built that kind of machine. He was right about the inline engine the same way he was right about rear-engine Indy cars and 400-mile-per-hour Bonneville runners. He was living in a future the rest of the sport took decades to reach. And the men who stopped him weren't better engineers. They were better politicians. Thompson kept building anyway. He always did. He was killed in 1988 at 59, and the sport he shaped was poorer for losing him that early. But his legacy stands not just in the records and the trophies, but in every race car engineer today who thinks about frontal area and aerodynamic packaging before they think about adding another 100 horsepower. That engineer is following a path Thompson cleared 50 years ago. The Autolite Inline never got its moment, but the thinking behind it won eventually. It just won without credit and without Mickey Thompson alive to see it. If this story stayed with you, hit subscribe. This is what Regal Rides is here for. Not the official version of American motorsport history, the real one. The machines that were banned, the builders who were buried, the genius that deserved better. We'll see you on the next one.